We're in Chapter 5, doing section 4. Now, Section 3 of Chapter 5 has to do with matrices. So if you're unfamiliar with matrices, you may want to do that too before you proceed to Section 4. In Section 4, we have some definitions for an eigenvalue, eigenvalues, and eigenvectors. So if I have a matrix A, then the eigenvalue values associated with the matrix A can be calculated by going A minus lambda I, taking the determinant of that vector. I is the identity matrix 1 0 0 0 1 0 0 0 1. If my matrix happens to be 3 by 3, setting it equal to 0 and solving for the lambdas. And in so doing, if I have a 3 by 3 matrix A, then I'm going to have 3 eigenvectors, eigenvalues, lambda 1, lambda 2, lambda 3. Once I have the eigenvalues, so these are eigenvalues, 1, 2, and 3, then I solve for the eigenvectors. And the eigenvectors are going to be solved by going A minus lambda I times some eigenvector is equal to 0, and then I'm solving for the vector v. So I would go case 1, lambda 1 is equal to whatever it is, and then I go A minus whatever that is, I, v, and solve for 0, and then call that v1 the eigenvector associated with lambda 1, the first eigenvalue. Okay, so that's how I'm going to solve for eigenvectors and eigenvalues. So I've got some matrices 1, 2, 3, 0, 2, 1, 0, 0, 3. So that's my matrices A. And now I want to find the eigenvectors, A minus lambda I, and I want to take the determinant of that and set it equal to 0. So I've got 1 minus lambda, 2, 3, 0, 2 minus lambda, 1, 0, 0, 3 minus lambda, and I take the determinant of that, and I end up getting 1 minus lambda, 2 minus lambda, 3 minus lambda, plus 0 plus 0, minus 0 minus 0 minus another 0, is equal to 0. So my lambda values are going to be 1, 2, 3. And then I find for, I say, case 1, lambda 1 is equal to 1. And then I go A minus lambda 1I, v1 equal to 0, and then I figure out what v1 is equal to. Okay, so I've got, if I remember what A was, A 1, 2, 3, 2, 1, 3, 0. So I would have 0, 2, 3, 0, 1, 1, 0, 0, 2, v1, 0, 0, 2, v1, okay. And that is equal to 0. So by inspection, v1 is going to be 1, 0, 0. And that works, so I would keep that. And then case 2, lambda 2 is equal to 2. So I'd have, if I want a minus 2I, v2, and I set it equal to 0, then I'd have minus 1, 2, 3, 0, 0, 1, 0, 0, 1. And times v2 is equal to 0. And then by inspection, I'd say v2 is equal to absolutely nothing. Okay, so I would go with 2, 1, 0. So 2 times minus 2 is minus 1 is minus 2, plus 2 is 0. These guys are all 0. So now I've got v2. Case 3, lambda 3 is equal to 3. So I'm going to take a minus lambda minus 3 I times vi, v3. I'm going to set it equal to 0. And so I'm going to have minus 2, 2, 3, 0, minus 1, 1, 0, 0, 1, 0, 0, 0, 0, 0, 0, v3 is equal to 0. So I say v3 is equal to, by inspection again, and I would go with 3, 0, 2. And those would be my 3 eigenvectors. Clearly, the eigenvectors can be any multiple of those numbers. We picked the easiest one. So we wouldn't pick 1, 0, 2 over 3, for example, though that would be perfectly okay to pick. We wouldn't pick that. Okay, so that's the how I would find an eigenvector and an eigenvalue. And then I've got an idea that Theorem 1 says if I have a vector x prime is equal to ax, so I've got x prime 1, x prime 2, down to x prime n is equal to a 1, 1, a 1, 2, out to a 1 n, down to a n 1. So I got some matrix that has to be squared times x1, x2, x3, down to xn. If I have something that looks like that, then I can solve, I can use this a, solve for the eigenvectors and the eigenvalues, and I can come up with x of t is equal to v e to the lambda t, where x is a vector, v is are the vectors, and lambda are the eigenvalues. So I have x1, x2, x3, x to the n, so those are all my values of n, are v1 e to the lambda 1t plus v2 e to the lambda 2t plus blah 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 out to vn e to the lambda nt. So I'd have all those values. And then these v1, v2, v3s are vectors that are n long. Have it'd be n by 1, n by 1, vectors. Okay, so that's the whole theory of the thing. And when we get done, we have to check our work to make sure it's right. Okay, so now we'll look at the problem set and make sure that we can do any of them. Okay, so I'm going to look at problem number 2 in section 5.4, and I have x prime 1 is equal to 2x1 plus 3x2, and I've got x2 prime is equal to 2x1 x2. So I've got something that's in the form x prime is equal to ax, where my A is a matrix that is 2, 3, 2, 1. Okay, so now I'm going to we need to find the eigenvalues. So I'm going to take A minus lambda I, take its determinant, and set it equal to 0. And so I'm going to have 2 minus lambda, 3, 2, 1 minus lambda. Determinant is. Now for the determinant, 2 minus lambda times 1 minus lambda minus 6 is 0. I'm going to multiply it out. I'm going to go and factor it and get lambda is equal to minus 1 and 4. And then I'm going to say case 1, lambda 1 is equal to minus 1. Okay, so I got A minus a minus 1 I. V1 is equal to 0. So I'm going to have 3, 2, 2 times V1 is equal to 0. So by inspection, I'm going to have V1 is going to be minus 1, 1. And then I'm going to go and find case 2. Lambda 2 is equal to 4. And I want A minus lambda I V2 to be 0. So I will have minus 2, 3, 2 minus 3, V2 is 0, and I end up by inspecting saying that V1 is equal to 3, 2. I look at V1 and V2 to make sure they're linearly independent of each other, and they are, so that's the case. So x of t is going to be V1 e to the lambda 1t plus V2 e to the lambda 2t, which is going to be minus 1, 1 e to the minus 1 minus t plus 3, 2 e to the 4t. And this would be x1 of t, x2 of t if I wasn't writing it as a vector. Okay, so now I know that x1 is going to be minus e to the minus t plus 3 e to the 4t, and that my x2 is going to be e to the minus t plus 2 e to the 4t, And now I want to check my work. So I'm going to check my work. And my original problem said that x1 prime was supposed to be 2x1 plus 3x2. Okay, so x1 prime would be e to the minus t plus 12 e to the 4t, and that's supposed to be 2 times x1 minus e to the minus t plus 3e to the 4t times plus 3 times x2, which is e to the minus t plus 2e to the 4t. Okay, and I've got minus 2 plus 3, which would be a plus e to the minus t. I've got 6 plus 6, which is 12, e to the 4t. My solution checks. I would then check my other solution. x2 prime is equal to 2x1 plus x2. And then I'd say, well, what is 2x prime? That'd be minus e to the minus t minus e to the minus t plus 8 e to the 4t, and that's supposed to equal 2 times x1 minus e to the minus t plus 3e to the 4t plus x2, which is e to the minus t plus 2 e to the 4t. Okay, and I've got minus 2 plus 1, so I got e to the minus e to the minus t. I've got 6 plus 2 is 8, e to the 4t, and my solution checks. So that's how I'd work the problem. I'd find the eigenvectors, I'd find the eigenvalues, I'd then check my work, and then I'd say I'm done. Okay, we're moving on to number 6. We're not quite done yet, because there's also a constant of integration sitting in front of both of those. So there's still a constant of integration sitting in front of both of these guys. But because it's a constant, that's perfectly okay. Without an initial condition, we can bring it out. But there are constants of integration sitting in front of both of them. Okay, I'm going to do number 6. The reason I think about the constant of integration now is because in number 6 we have initial conditions. Okay, doing number 6 again. x1 prime equals 9x1 plus 5x2. x2 prime equals minus 6x1 minus 2x2. I have x prime is equal to 9, 5, minus 6, minus 2, x. I'm looking for the eigenvalues, so I'm going to have a minus lambda I. The determinant of it, I'm going to set it equal to 0. 9 minus lambda, 5 minus 6 minus 2 minus lambda. I'm going to have 9 minus lambda times minus 2 minus lambda minus a minus 30, making it plus 30, is equal to 0. Okay, I got minus 18 minus 7 lambda plus lambda squared plus 30 is 0. I have lambda squared minus 7 lambda plus 12 is 0. And I have eigenvalues that are 4 and 3 again. Okay, now I'm looking for the eigenvectors. So I'm going to go case 1. Lambda 1 is 3. So I'm going to go A minus lambda I times V1 is going to be set equal to 0. So I have 6, 5, minus 6, minus 5, V1 is 0. So V1 is going to be minus 5, 6. Okay, case 2. Lambda 2 is equal to 4. So A minus lambda I, set it equal to V2, times V2, I'm going to set it equal to 0. So I'm going to have a 5, 5, a minus 6, a minus 6, V1, V2 is equal to 0, implying by inspection V2 is equal to minus 1, 1. V1 and V2 are in fact linearly independent. So x of t is going to equal c1 v1 e to the lambda 1t plus c2 v2 e to the lambda 2t, c1 times minus 5, 6, e to the 3t plus c2 minus 1, 1, e to the 4t. So I've got x1 of t is equal to minus 5 c1 e to the 3t minus c2 e to the 4t. And I've got x2 of t is equal to 6 c1 e to the 3t plus c2 e to the 4t. I have two initial conditions. X at 0 is 1. X1 at 0 is 1. So I got minus 5 c1 minus c2 is equal to 1. And then I've got x2 at 0 is 0, 6 c1 plus c2 is equal to 0. I add these guys together and I see that c1 is 1. If c1 is 1, then c2 has to be minus 6. And now I got a set of equations that say x1 of t is equal to minus 5 e to the 3t minus 6 e to the 4t. No, plus 6 e to the 4t. And x2 of t is equal to 6 e to the 3t minus 6 e to the 4t. And that would be my final answer. Now I'm going to check my work. Check my work, and I have that x1 prime from the original problem is 9x1 plus 5x2. So x1 prime is going to be minus 15 e to the 3t plus 24 e to the 4t, and that's supposed to equal 9 times minus 5 e to the 3t plus 6 e to the 4t plus 5 times 6 e to the 3t minus 6 e to the 4t. Okay, so I got minus 45 plus 30. That checks. That gives me minus 15. I've got a 54 minus 30, which is 24. That checks. Okay, I'm going to try it again. X prime 2 is supposed to be minus 6x1 minus 2x2. Well, x2 prime would be 18 e to the 3t minus 24 e to the 4t, and that would be equal to minus 6 times minus 5 e to the 3t plus 6 e to the 4t minus 2 6 e to the 3t minus 6 e to the 4t. I've got plus 30 minus 12 giving me 18 e to the 3t. I've got minus 36 plus 12 giving me 24 e to the 4t. My solution checks.
Everything's good.
Right. Moving on to, well, I think that's probably enough.